What happens to light waves when they encounter objects? Do they go through the objects? Do they bounce off the objects? When a light wave strikes the surface of an object, a variety of things can happen. One of these things is called resonance. When resonance occurs between a light wave and an object, the object absorbs the energy of that light wave. The light energy stays inside the object when resonance occurs. But what about when resonance does not occur? What happens to light waves that are reflected off the object or transmitted through the object? In this lesson, we're going to study light waves a little further in order to understand transparency and opacity. An object is said to be transparent when light passes through it without being dispersed or scattered. Clear glass is transparent and clean water is transparent. Although light travels through these materials, we know that they also block things like wind, sound waves, and the movements of people and animals. For example, you can't walk through glass, so how can a light wave pass through the glass without being changed at all? Light waves are absorbed by an object when the frequency of the light wave matches the resonant frequency of the object. Absorption occurs when none of the light waves are transmitted through the object. Transmission, if you weren't sure, just means the passing of electromagnetic waves through a material. In the case of objects that are transparent, all of the light waves pass through. Transparent objects exhibit complete transmission of the light waves through the object. What really happens inside glass materials when a light wave passes through? We know that there aren't any tunnels connecting one side to the other, so what's going on? When a light wave strikes the surface of the glass, it sets the electrons vibrating at a certain frequency. This frequency is not the resonant frequency of the glass. The vibrations pass from the surface atoms to the neighboring atoms and then on to more atoms through the bulk of the glass. The frequency doesn't change when the vibrations pass from one atom to another. Once this energy gets to the other side of the glass, it is re-emitted from the opposite surface. The light wave effectively passes through the glass unchanged. As a result, we can see straight through the glass, almost as though it isn't even there. So now you know. Transparency occurs because of the transmission of light waves through the bulk of an object. What about objects that are translucent? What's happening when light is scattered as it passes through an object? The scattering of light is related to a subject called refraction, but we won't be discussing that in this lesson. We're going to talk about opaque materials next. So we've learned that light waves are absorbed when they resonate with an object. They're transmitted when they pass through the atoms of an object. But what if the light wave does neither of these things? When a light wave is neither absorbed nor transmitted by an object, then it is reflected. Reflection is a change in the direction of a wave when it strikes a surface. Reflection can be specular, as in glossy or smooth surface objects, or it can be diffuse, as in objects with rough surfaces. In either case, reflection occurs because the vibrations of the surface electrons do not pass their energy down to the material. Instead, they vibrate a little bit and then re-emit the energy back away from the material. When this happens, the object appears to us as opaque. Opaque materials do not allow transmission of light waves. In other words, we can't see through an opaque object. We can only see the surface because the light waves are re-emitted from the surface back to our eyes. Opacity occurs because of the reflection of light waves off the surface of an object. Now, I bet you're wondering, what about the different colors of opaque materials? Why does my car look red when my friend's car looks blue? Well, again, you're going to have to hold that thought. Color is related to the selective absorption of different wavelengths of visible light. For now, just keep your mind on transparency and opacity, whether or not we can see through an object or material. Transparency and opacity are easy enough to understand in the context of visible light. We can see the results of it, can't we? We can see when an object is transparent to a light wave. We can tell when something is opaque. But the principles of transparency and opacity apply to all the electromagnetic waves. Visible light, remember, is just one of those types. So here's a question. If glass is transparent to visible light waves, does that mean it's transparent to the other EM waves? The answer, surprisingly, is no. Transmission and reflection happen differently for every type of wave. So the rules about which objects are transparent and opaque also change. Glass is transparent to visible light, but opaque to infrared. Silicon is transparent to infrared, but opaque to visible light. What does this mean? It means that if your eyes were designed to pick up radiation in the infrared range, then you would be able to see through silicon, and you would not be able to see through glass. Weird. You may already have a sense of what is transparent or opaque to different kinds of waves. How do you protect your skin from the harsh UV rays of the sun? By wearing sunscreen, of course. Sunscreen is opaque to ultraviolet light, but it's transparent to visible light. This is why you can still see your skin when you're wearing it. X-rays follow different rules. Materials like skin and blood are transparent to X-rays, but bone and metal are not. This is why we can see bone and metallic objects in contrast to skin and soft tissue in radiographic images. The transparencies and opacities of the different EM waves dictate how we use modern technology and materials. Radio waves pass through brick walls, but not through steel. Gamma rays pass through outer space, but not through our atmosphere. Just imagine strange things you would see if you could perceive light in the other regions of the electromagnetic spectrum. What if you could see through the walls of a building and still be unable to see the skin of your hand? In the end, I guess I'm glad that I can only see with visible light. The transparency and opacity of objects depends on how light waves interact with the materials of those objects. Light waves cause vibrations in surface atoms, which are either absorbed, transmitted, or reflected. Transparency is caused by the transmission of light waves. If the vibrational energy of a light wave is passed through the object, then the object appears clear or transparent. If the energy only causes vibrations in the surface before reflecting off the object, then the object appears opaque. Therefore, opacity is caused by the reflection of light waves. While we typically use these terms to describe our perceptions in the visible light range, they also describe interactions in the other regions throughout the EM spectrum. Materials that are opaque to one type of wave may be transparent to another type. Therefore, transparency and opacity are relative terms that vary by region of the electromagnetic spectrum.